So moving on to the last part of this paper, we have 4 problems which look of the type 4 cross 4 match the column, but you can see that we have written below the correct option is. So you just have to find out which of the following options is correct out of A, B, C, D. So we can make a very suitable use of PNC by looking through the options and solve the corresponding options because it is just a 4-mark problem. Okay. So we will smartly solve this question. Okay. Question number 51 says that let the roots of the quadratic equation ax square plus bx plus c equal to 0 where a is non-zero, be alpha and beta. Then list 1, 4 different quadratic equations are given. List 2, 5 different roots are given. Students, this is a clear-cut problem of the transformation of roots. Okay. What we have to do? We have to find out an equation whose roots are alpha upon alpha minus 1 and beta upon beta minus 1. So let us put x equal to alpha upon alpha minus 1. From here I will get alpha equal to x upon x minus 1. What are we supposed to do? Alpha is a root of ax square plus bx plus c. Alpha satisfies it. So a alpha square plus b alpha plus c is equal to 0. Put this value of alpha over there in order to get the transformed equation. So a into alpha square plus b into alpha plus c equals to 0. This is the new transformed equation. This is ax square plus bx into x minus 1 plus c into x minus 1 whole square is equal to 0. You can easily collect the coefficients. It will be a plus b plus c of x square. Now it will be minus bx minus 2cx plus c is equal to 0. So you can see that a plus b plus c x square minus x, if we take common, the coefficient is b plus 2c. So option number 1 on the list 2 has p as the correct match in list A. So p goes to 1. Let us rule out the options. Option number A and option number D are ruled out. If p is 1, we have to check for either q or r or s because all 4 are different. Carefully looking at this particular expression which is given in the third one, it is exactly negative of this one. So the answer will contain minus x in place of x. So the answer of C part will be a plus b plus c x square plus bx plus 2cx plus c equals to 0. So that means option number 3 in list 2 matches to option number R in list 3. So P matches to 1, R matches to 3. Option number B also gets rejected. Correct option is option number C. So you have to smartly work out through the given options and through the given combinations. Okay, let us move on to next question. Question number 52. Let lambda f denotes the number of integers belonging to the domain of fx. 4 functions are given. Let us go through the options first of all. P1 or 4, Q2 or 3 or 4, R2 or 4. For S, I have all the 4 different given options. 2, 5, 3 and 1. So all I need to do is I have to solve only S part. S part is 34 raised to the power fractional part of fx plus 2 raised to the power x is equal to 36. 34 raised to the power fractional part fx plus 2 raised to the power x is equal to 36. So let us calculate fx. 34 raised to the power fractional fx is equal to 36 minus 2 raised to the x. Fractional fx is log 36 minus 2 raised to the power x to the base 34. Okay. Now students, fractional part of any quantity in mathematics always lies between 0 to 1. So the right hand side always have to lie between 0 and 1. 0 is closed, 1 is open. 36 minus 2 raised to the power x. That will be the condition of domain. Less than 1. Now this is 1 less than equal to 36 minus 2 raised to the power x less than 34. Subtracting 36 from everywhere, minus 35 less than equal to minus 2 raised to the power x less than minus 2. Multiplying with a negative sign gives me the opposite side of inequality. 2 less than 2 power x less than equal to 35. Students, we just have to calculate how many integers belong to the domain, we just have to put the values of x. X equal to 1 will not be allowed here because there is an open interval at 2. X equal to 2 is possible, x equal to 3 is possible, x equal to 4 is possible, x equal to 5 is possible. 2 part 5 is 32. 32 is less than equal to 35. 6 is not possible. So how many integers are belonging to the domain of S part? 4 integers. 4 means option number 3. S matches to option number 3. The only correct option is option B. Okay. Again, you have to work smartly. Let us move on to next part. Question number 53. Let lambda f denotes the number of solutions of the equation fx equal to 0, which belong to the interval 0 to 2 pi. Again, looking out of the options, p is either 1 or 3, q is either 1 or 3, r is either 4 or 5, and s is either 1 or 2. So we have to solve p first of all. f1x. You have to find out fx equal to 0. So sine cube x minus sine x plus 1 equals 0. 1 equal to sin x into 1 minus sine square x. Okay, 1 minus sine square x is cos square x. So sin x into cos square x is 1, which means that cos square x is equal to cosecant x, which is never possible because the range is 0 to 1, the range is 1 to minus infinity to minus 1, union 1 to infinity. And both of them simultaneously can never be equal to 1 because if cos square x is 1, cosecant x is not defined. Okay? So we have no solution. No solution means p matches to 1. So if p matches to 1, this option is rejected, this option is rejected. We don't need to solve q. Q also has to match to 1 only. Again, no need to solve r. R matches to 4. We have to solve s now. So solving s, I have f4x equal to tan square x plus sin square x minus secant square x minus sin x minus 1. Secant square x minus tan square x is 1. Tan square x minus secant square x is minus 1. So this is sin square x minus sin x minus 2 equals to 0. That is sin x into sin x minus 1 equal to 2. Sin x minus 1, a quantity lying between minus 2 to 0. Only possible solution is sin x equal to minus 1. Sin x equal to minus 1, I'll get minus 1 into minus 2, that is 2. Students, be careful. When sin x is equal to minus 1, secant x is not defined. That means this violates the domain of the function f3x. That means s will match to 0. That is option number 1 in list 2. 1, 1, 4, 1. Option number D is the correct choice. Okay. Don't solve all the 4 parts. They are very easy. You just have to crack the code. So now let us move on to 54. Okay. So coming on to the last question of this paper. Consider two complex numbers z1 equal to cos alpha plus iota sin beta and z2 equal to cos beta plus iota sin alpha, where iota is under root of minus 1. And alpha and beta belongs to 0 to 2 pi, the complete angle. Let real part of the complex number z1, z2 be unity. All the 4 parts are related to z1 and z2. We have to solve all the 4 parts. Else we have to solve at least z1, z2 and the condition given above. So z1, z2, the real part of the complex number is unity. What is the real part of z1, z2? It will be first real part of z1 into real part of z2, cos alpha cos beta plus iota square times sin alpha sin beta. That is minus sin alpha sin beta. That is equal to 1. Cos of alpha plus beta is equal to 1. So students, alpha plus beta is equal to 2 n pi. Beta is 2 n pi minus alpha. As soon as we got this relation, when we use it, everything will become simple. So z1, which was cos alpha plus iota sin beta, now it is cos alpha plus iota sin 2 pi minus alpha. So cos alpha minus I sin alpha. It was cos beta plus I sin alpha. Now it is cos alpha plus I sin alpha. Because cos of 2 pi minus alpha is cos alpha, fourth quadrant. Simple. everything is simple now. Mod Z1, mod Z2, both are equal to 1. 1 plus 1 plus 1 plus 1, 4. Maximum value of mod of Z1 plus Z2. Z1 plus Z2 is simply 2 cos alpha because they are the conjugates of each other now. 2 cos alpha, what is the maximum value? 2. Option number 3. Mod Z1 minus mod Z2. Mod Z1 is 1, mod Z2 is 1. 1 minus 1, 0. Matches to 1. Argument of Z1 upon Z2 conjugate. Z2 conjugate is same as Z1. So argument of Z1 upon Z1, that is argument of 1, is equal to 0. N pi by 8. N has to be 0. 4, 3, 1, 1 is the correct order. Option number C is the correct choice. Okay. So with this, we come to the end of the discussion of paper 2 as well. I hope that you have improved a lot of concepts after appearing in this paper, and I hope you have understood all the solutions properly. Okay. Thank you very much. We'll see you again very soon.